What's up, Fox Lane? 6 West. Another super exciting science class. Today we're going to be talking about layers of the Earth. If you were in my Google Meet on Monday or Wednesday, you heard this speech kind of already. I'm going to go into a little bit more depth because, this is today's lesson. But if you did come to Monday or Tuesday's Google Meet, you could kind of pause right here, try to answer the questions below. And then if you miss anything, jump back into this video. For everyone else, this is going to be new for you, although between the two, we did have a lot of 6 West students, but if you didn't come to Monday or Wednesdays, this is brand new. So these are the layers of the Earth. And I like comparing the layers of the Earth to a cake or to like a slice of pizza, because that's actually how it's cut out here. It would look, obviously like a full circle. Okay. And the reason why, or one of the reasons why I became a neuroscientist is because it was something that was real. And this is real. This is what actually is going on below our feet. We live on something called the continental crust. Okay. Continental crust. We're land. That crust is different than our oceanic crust. Okay. Oceanic crust is much thinner. Continental crust is much thicker. Okay. So it's like you get that thin crust pizza, that's more like an oceanic crust. If you get that thick pizza, that thick crust, that's more like a continental crust. We live on this area. Okay. And it's much thicker underneath our feet. Underneath the crust is a layer we have called the mantle. There's really only 4 layers. Hint, this is question number 1. There's only really 4 layers of the Earth, but the mantle kind of gets special rights because it's a little different, which is also a question. So the continental crust and the oceanic crust, that's just labeled as the crust. All right, that's the outermost shell of of the Earth. That's the part that has cooled down in the 4.6 billion years. And we could see that that's the only cool part of Earth, and everything underneath it is still really hot. As you move farther down to the core, we get even hotter. The core is the hottest. The temperature of the core is about 8,000 degrees, which is hotter than some of the surface of the sun. Not about the whole sun. We're just talking about the outermost layer of the sun. Our core is just as hot as that, and it's below our feet. And that generates a lot of different things that's happening below our feet that has changed the way that Earth has looked over the 4.6 billion years that's been in existence. But as we dig down deeper, we have the crust, which is the outermost layer. Then we have the largest layer of Earth, which this one doesn't do format, but we'll see it a little bit earlier. This is called the mantle. The mantle is going to be the bulk of our Earth, okay? It's much larger than the other two. Again, this is not drawn to scale. But the mantle would include half of this thing called the lithosphere and this thing called the asthenosphere, as well as the lower mantle. So all of those are together. Now, to make it kind of confusing, the lithosphere, this guy, is part of the upper mantle and part of the crust. And the reason why the lithosphere is part of the mantle and part of the crust is because that's the really solid part, okay? So you can see over on this little insert, the upper solid mantle, that's what we're going to call, and the crust, that's what we're going to call the lithosphere. Now, that gets its special rights because those are solid pieces. Those are, almost diggable. I mean, the crust is obviously diggable. You get into a lot more heat once you got to the upper solid mantle. But these are going to be things that are going to be really sticking together. The asthenosphere, which is kind of the middle layer of the mantle, is something that we call ductile. All right. And that means that it can move. All right. So ductile means that you can move it or bend it. Now, it's not like flowing water. I would kind of describe the moving part of the mantle as something like a melted plastic. If you ever melted plastic before, you could bend it, you could reshape it, but it moves slowly. It's not like flowing liquid or lava like you have seen. So it's bending, and it is movable, but it's not moving, extremely fast. And we'll talk about that a little bit later. And then we just have the lower part of the mantle. So just to recap, we have the crust, the mantle, and then we get to this thing called the outer core. The outer core and the inner core are made up of the same thing. They're both made up of iron and nickel. But here's a question. The outer core is liquid and the inner core is solid. So the outer core is iron and nickel in liquid stages, and the inner core is iron and nickel in its solid stages. Now, when the Earth was created, and we showed that video way back when in October, and it was formed from gravity pulling all of those boulders in space together, it was formed as a entire ball of liquid, that molten rock. And what happened is, just like the density, if it's all liquid, the things that are more dense are going to flow to the bottom. Okay. So like when we put in honey and water, the honey was more dense than the water, so it flowed to the bottom. So if the earth was all liquid, what happened is the heavier metals sank down to the middle where gravity was pulling it. All right. Now remember, this is a giant circle. So the inner core is actually the core. It's the center. It's not just the bottom of this column, it's the bottom of every column coming in from all directions. And as we get towards the middle, it makes it hotter. Now that's going to make something happen because there's uneven heating. On Earth's crust, you can have 0 degrees Fahrenheit. You can have 100 degrees Fahrenheit. You can even have 134. That's the record. Degrees Fahrenheit. All right, in the United States, that's the record. But when we compare that to 8,000, it's not even close. This is much colder than the inner core. Now, when we talked about the atmosphere, when things are unevenly heated, that's going to create something called a convection current. Now, as I scroll down past your questions, down any further. Awesome. Well, there'll be a graphic on the bottom, but it's obviously not working for me. Um, what happens here is you get uneven heating. And because this layer is ductile, right, it can move. When it's heated on the bottom, that's going to make this material down here less dense and it's going to rise. But as that material gets towards the top that's cooler, it's going to become more dense and sink. And that back and forth of sinking and rising is what we're going to call a convection current. It's all caused, this is a question number 7, it's all caused by uneven heating of the earth. And as that material comes up, and then circles back down, it actually is going to pull the crust with it. It's like laying on a float in water, right? Except this doesn't move as freely as water, but it's like moving on a float on water. And when someone, if there's a current, if someone's swimming underneath you, you're going to kind of move in the direction that it's moving. And over the course of 4.6 billion years, these convection currents that have been circling in different ways underneath our feet have been moving the slabs of Earth's crust into different directions, and we have looked very different. There's been times on Earth where we've had one supercontinent, the last one known as Pangea, and there's been times where that continent has been broken apart. There's been more than one supercontinent. There's been more than one time where we've had multiple continents, right? Like we have 7 right now. And that's all caused by the convection current from the uneven heating of Earth that happens in our mantle. Okay, so just to end the video for today, we have the crust, we have the mantle, we have the core. The mantle is broken up into 3 spots: the lithosphere, which is half mantle, half crust. Then we have something called the asthenosphere, and then we have something called the lower mantle that's not pictured here. I'm not going to be really asking you guys that much about the lithosphere and the asthenosphere, but just know that there's the crust, oceanic and continental, the mantle, and the outer core and the inner core. So good luck on your questions. Watch this video. I think I answered everything in here. Um, as we move forward, you could feel free to look it up. Um, so as we go down towards the core, it gets more dense. All right, guys. So hopefully everything's going well. If you have any questions, feel free to email me, and we'll talk soon. Have a good day, everyone.